All right, so welcome back again. And that's the problem of using a free stuff. You don't have quality service at the end of the day. So let's manage with this until maybe we are fortunate to upgrade to the subscribe one. Things will be better. Okay, so let's continue from where we stopped.
Okay.
So we have this. Now we have solved our model, which is 1 over 1 minus b. In bracket, we have a and the investment. Then for c also, we have solved it. What we have is said a plus b times the investment, which is constant, all over 1 minus b. So now the values of these parameters and coefficients are given to us. They said investment is what? 100. And they said a parameter is what? 500. And the last one, which is the marginal propensity to consume, is 0.8. So all what we have to do to solve question 2 is to substitute. So if we want to find y, it's very simple. We know this is 1 over 1 minus b. And what is b? B is what? 0.8. We substitute.
Yes.
So then in bracket, we have 500. And plus the investment. And investment is what? 100. So we do the same thing for consumption as well. A is what? 500 plus 0.8 times the investment, which is 100, all over 1 minus b, and b is what? 0.8. So what we will have here is, I don't want to skip steps, but this will give us 0.2. If you checked it in total, I think should be 5. This. So this plus this should give us 600. So let's finish this one. So this will, y will be equals to 5 times 600. So at the end of the day, our consumption, sorry, our GDP, which is the output, y represent this, y represent, remember, the GDP of a country. I think we have seen we know what GDP means. It's the total goods and service produced in a country within a specific period of time. So 5, this will give us 30 and the 2 zeros. So if we come here with, at the consumption side, we will have C equals to 500 plus 80. How do we get 80? 0.8 times 100, we have 80. Then 1 minus 0.8 will have 0.2. So at the end of the day, this will give us what? 580 divided by 0.2. So C will give us 580 divided by 0.2 will give us 2,900 unit of consumption. So then we have solved, this is how you go about solving macroeconomics models like this. Any questions before we go further? We start quadratic. Okay, so we know the goal, initially the goal was, the first question asked us to solve this. This is our first question. It says that solve the model in terms of y and c. We did that. Then it gave us some numbers to find the numerical value of y and c, which we did as well. So we have seen another application of linear equation. If you looked at this, what we have been doing so far is linear equation, because the variable that are within the equation, the highest degree there was 1. So this is another application. So normally this is my income. Some people call this model income determination in macroeconomics. It's income determination because GDP is the same as income or output. Income and output, they are, people use them as the same terms. Some people call income, product, they are the same. So this model, they are called income determination. So we can use linear model to determine the GDP or the output produced in a particular country within a specific period of time. So after this, now let's look at quadratic equation, and let's look at the structure of quadratic equation and how do we solve them in a start. So once we finish this chapter 1, that is solving equation, we will be looking at function of one variable. Then from there, then we will be looking at differentiation, or some people call it derivative. It's more of what we are doing. We are preparing towards starting calculus, which I think most of you haven't seen it in high school. So, but these preparations are important so that we won't have any hitches when we start calculus, that is derivative or differentiation. So let's go to quadratic equation. Okay, let's look at quadratic equation. First of all, it's important we know their structure. It's important when we see equation, we should be able to know whether they are quadratic or linear. And I think we have talked about that in our last class already. But first, let's look at the structure, the general form of quadratic equations. How do they look alike? So, which first, if you look at quadratic equation, normally it has this kind of structure. We have bx plus c equals to 0. But the condition, it has one condition, that is a cannot be equals to 0. Why? Because if a is equals to 0, then this term, it will go off. And the quadratic equation, if a equals to 0, this will go off. So it will remain only this. So the quadratic equation will change into linear. So that's why any quadratic equation, if you look at the textbooks, any textbook, it will tell you a cannot be equals to 0. Because if a is equals to 0, then the quadratic equation will turn into a linear equation. So this is the first condition that must hold for us to have a quadratic equation. So after that, you understand, normally people go on to make this, how do we know it's a quadratic equation? First, the variables here are what? This one, that is the x, and this x, they are the variables. Yeah. So if you look at C, C is nothing but a constant. So this B is the coefficient. It's a coefficient. This A also is a coefficient. We have talked about all this. So I'm going to rewrite this. So then this equals to 0. So if you look at it, why do we call it quadratic? We have two variables, this one and this one. So we have the power here is 1, the power here is 2. So if you look at this equation, the highest power that a variable is having is 2, which is this one. So it's because of this 2, then we call it quadratic equation. But it's also important we make this identification. Let me rewrite the equation again. Plus bx plus c. So what we are learning so far is the terminology when it comes to quadratic equation. This first part, normally they call it the quadratic term. Please understand these terminologies because I will be using them when I'm talking quadratic term. So this term is the linear term. I know this very well. It will be very handy, maybe in next 10, 15 minutes. So this is the quadratic term, sorry, linear term rather, linear term. And then we have C as the constant term. So know all these terminologies: quadratic term, linear term, then constant term. So this one, A is a coefficient, B is a coefficient, C is a constant. So the variable there is this one and this one. So most often also, this is important, we know it as this well. So most often people will also try to make the quadratic term to stand alone. And how do they do that? They divide both sides by A. For example, like this. We have this ax to the power of 2 plus bx plus c equals to c. It's 0 rather, equals to 2. So we want x squared to stand alone. We divide both sides or throughout the equation by a and this. So at the end of the day, we cancel this. We cancel this. So what we will have x to the power of 2 plus b over a x plus c over a equals to 0 divided by a is 0. 0 divided by any number is 0. So we have this. So if you look at these terms, they are fraction. They don't look, they make the equation to look ugly. So normally what textbooks will do, they will say that let's assume, or in fact, let's say just say not assume, let P represent B over A, and let Q represent C over. So since we let these things to represent B over A and C over A, we can restate our equation again and say x to the power of 2 equals to B over A. But we said B over A is equals to P, so we bring the P here. X plus C over A. But we say let P over A is represented by Q. So we write Q equals to 0. We have that. So we have this as a standard quadratic term. So the question is, how do we solve this? How do we know? And when I say how do we solve this, I'm asking how can we find the value of x? Because here x are the variables. So when you are solving an equation, it's about finding the values or the numerical values of x. So how do we solve this? How do we solve this kind of equation, quadratic? How do we solve this? How do we solve this? Please mute your mics. The noise is coming a lot. All right. How do we solve this? How do we solve this? We have 3 cases. Case 1, which is very, very simple. Let's call it case 1. We have case 2, which is also very simple. And case 3, which is a harder case or a difficult case. So we are going to look at each of these 3 cases to see how we will be able to solve this kind of quadratic equation. Remember, still now, this is the quadratic term. Quadratic. Remember, this is a linear term or linear component. And remember, this is a constant term. So how do we solve this kind of equation, which is quadratic? Depend on which kind of cases do we have. And we will look at this one after the other. So let's go. Let's restate the equation again. Plus px q. So we have this equation. So the goal, remember, this topic or this chapter is all about solving equations. So how do we solve this? We said it depends on the case we have. So let's assume case one. In some quadratic equation, we will have a case. Let's say this is case one. In case one, sometimes you'll have what? Missing linear term. So what I mean by this, sometimes you have a case whereby linear term will be missing. That is, or in another word, when p equals to 0. So when p equals to 0, this equation, this is, remember, this is the standard format or the general. It has all the terms, one, quadratic, linear, constant, and the 0. But sometimes this component will be missing. X plus px plus q equals to 0. So sometimes you will see quadratic equations. This will be there. This will be there. However, this one will be missing. And why is it missing? Because p equals to 0. Because if p equals to 0, it will be like p times x, then this will be missing. And if p is equals to 0, or the linear component is missing, you will have a quadratic equation like x raised to the power of 2 plus q equals to 0. So we can have a case like this. If we have a case like this, what is telling you that this linear component or linear term is missing, and it is missing because p equals to 0. So how do we solve this kind of equation, a quadratic equation where the linear component is missing? In another word, p equals to 0. It's very simple. All what we do, there is a standard formula for it, but if you want also, you can go on and solve it. So, for example, this is a general form. Let's look at an example like this. So here, if we want to solve this, remember we are trying to solve this equation. What does it mean solving this equation? To find the value of x, not x raised to the power of 2. So all what we will do is to move, this is 2 please, this is equal to, this will come here and it will turn into negative q. Remember, we are not trying to find x raised to the power of 2, but we are only trying to find x alone. So all what we can do here is to multiply this by half. But if we do it on the left-hand side of the equation, we have to do it on the right-hand side. So this will cancel, so x will stand alone. So remember that when a number is raised to the power of half, it's meaning that you are finding the square root. And because of that, this has to turn into plus or minus, then we have this. And the condition here is what? This q should be less than or equal to 0. If you are confused, just wait. I'm coming over, we can, this. So this is the solution. When you have this kind of quadratic equation, whereby the linear component, this one, when the linear component is missing. But remember, the linear component is missing because p equals to 0. So if you have this type of quadratic equation where you have the quadratic term you have the constant term, but the linear component is missing, you can use this formula, this, to solve it. For example, let's take a practical example, like a real life example. Let's, as says, let's look at this one. For example, x raised to the power of 2 minus 4 equals to 0. If you look at this, obviously you should know that it's quadratic equation. Why? Because of this. But it's not a full standard quadratic equation because this linear component is missing. This is missing there. So obviously, we know that this will be our, remember that if you have this kind of quadratic equation, you can use this formula. X will be equals to plus or minus in bracket minus q. You can use this formula. So what is the goal here now is to find what is q. But remember, q equals to b over a. Remember, we did that. It's here. We said, sorry, c rather, c, not e. This should be c. So it's called c over n. So we have to find our c. If you look at our c is what? That is the constant term, which is minus 4. And our a is what? Is 1, which is here. This the coefficient attached to here. So at the end of the day, the q will be minus 4 over 1. At the end of the day, it will give us minus 4. So we know this. So all what we will have to do, we will substitute it here. So this q will be equals to, we bring this, plus or minus, q is what we said is minus 4. But remember, this minus is there. So it will be minus into minus 4. So at the end of the day, it will be positive. So this equation is already solved, equals to x equals to plus or minus. So that is, you can use this formula to solve it. But if you don't want to use the formula, you can go straight forward and solve this also. So you can just go on and say, if you don't want to use this formula, you can just say x raised to the power of 2 equals to, this will go here, it will be positive. So you want to get rid of this, you multiply it by half, you multiply here also by half. So you get rid of this already, so x will be what? Since this is a half, it means you are taking the square root of 4. Obviously it will change to 4, it will plus or minus square root of 4. So it will be x equals to plus or minus 2. So that's the solution. So if you don't want to use this formula, still you can go on and solve using it. Still it will give you the same answer. So we looked at our case 1 already. Case 1, where the linear term, this linear term, when it's missing, you can go on and solve it like this, or you use this formula. So that's the first case. But remember also, let's take another example whereby there will be no solution. We will have a missing term and there will be no solution. So let's take another example. So let's say that we said solve x raised to the power of 2 plus 3 equals to 0. So obviously, we know that this is quadratic, but it's not a standard quadratic because the linear component is missing there. We know that standard quadratic is like this: x raised to the power of 2 plus px plus q equals to 0. So if you look at normally is what? 1, 2, 3, 4. It has 4 terms, but here is 1, 2, 3. So something is missing. And what is missing is this. So we said that if linear term is missing within the quadratic, to solve it, you can use this formula. X will be equals to plus or minus square root of q negative q. If you don't want to use this formula, you can even go on and solve it. So let's look at them side by side. Using the formula, obviously we have to find the value of q. So we said that q equals to what? C over a. And what is our c? C is the constant, which is 3 plus 3 or 3. And what is a? Obviously a is 1. So then we substitute here. What are we going to have is 3 over 1 equals to 3. So then we bring this down. This is x equals to plus or minus. So minus, what is q? Q is 3. Can we solve this? Obviously no. So that's why they said that q should be less than or equals to 0. Because if it's greater than 0, then we will have a negative number here, and you can't find the square root of a negative number. So hence, there is no solution to this equation. We cannot find a square root of a negative number. So just check the difference between this problem and this other problem. Where is it? This one. There is a minus here. So there is a plus here. If there is a plus here in this type of situation, in this case, normally you don't have solution to the equation. So there is no solution to this quadratic equation. So if, as long as, because we said what? Q equals to 3. But the condition is what? Q should be less than or equals to 0, meaning that Q should be negative or 0. From 0, then towards negative number. If it's positive, then you cannot find a solution in this case. So we are going to, but if you don't want to use this formula, you can just go on and solve it as well. So we have this. Let's try to solve it without the formula. Plus 3 equals to 0. So what you will do, you collect the like term. This is constant, this is constant. So this will come here. Then it will turn into what? Negative 3. So we want to know only the value of x, not x raised to the power. We multiply it by half. We multiply here also by half. So this one will cancel, this one will cancel. So x equals to, since half, it means that we take the square root of negative 3. This will plus or minus minus 3. And if you take your calculator, you point this, it will not work. It might give you mass error because you cannot find the square root of a negative number. So what conclusion can we draw here is that there is no solution, just like here. You can use this formula to solve it, or you can just use direct solution. If you, at the end of the day, if you reconcile these two, they will give you the same answer. Because this one, this formula comes from these steps. So here there is no solution. We don't have a solution for this quadratic equation. There is no solution. So let's look at case 2. So let's look at case 2. So in case 2, we have the constant, let's say constant term is missing. Constant term is missing. And what does that mean? Q equals to 0. We know that the standard quadratic equation is like this. The standard quadratic equation, or the general form, Px plus Q equals to 0. So in a case like this case, where the constant term is missing, this will not be there. That is Q equals to 0. So this equation will turn into what? This raised to this plus px, this is 0, so hence equals to 0. So this is how the quadratic, if you see any quadratic equation looking like this, what it means is that the constant term is missing. So how do we solve this kind of equation? How do we solve this kind of equation? It's very, very simple. What we can do, we can use the formula, or if you don't want to use the formula, you can still solve it. So if you want to know, solving this meaning that we want to find the value of x. So if you have a quadratic equation that look like this, or is having a missing, the constant term is missing, or the q equals to 0, the solution is very simple. The first solution will be x equals to 0, or x equals to minus p. So we all know how to find p. It's very simple. So let's take a practical example, or an example that are having numbers, and try to solve this. For example, let's look at this example. 5x minus 8x. 5x minus 8x equals to 0. So if you look at this equation very well, you will realize that if you look at the standard quadratic equation here, it has how many terms? 4. 1, 2, 3, and then 4. But here is having what? 1, 2, 3. So something is missing. And if you look at it, the quadratic term is there. The quadratic term will always be there. So we look at the linear term is there. So we realize that the constant term is what is missing. So if you know that is the constant term that is missing, or is the q that is equals to 0, if you want to solve this, you can just go on and use this formula and say the solution is what? X equals to 0, or remember also for quadratic equation, they have two solutions. So if you look at, let's go back. We have here x equals to plus or minus 2. What it means is x equals to plus 2, or x equals to minus 1. So minus 1. So quadratic, they have two solutions. Some people call this the root of the equations, but we will look at this very well when we start graphing their solutions. But always remember that this plus or minus 2, it means that x equals to plus 2. That is, it has two solutions, or it has two roots. X equals to minus 1. Okay, let's get back. So we can use this formula, that is x equals to 0, or x equals to minus p. So we need to know what is p. We have defined p already. We said what p is what? Is equals to b over a. We define p as this. B over a. So we know what is our b. What is our b? This is our a. This is our b. So p will be, what is our b? 8 over 5. So the solution will be x equals to 0, or x equals to minus p, and p is what? 8 over 5. So this is our solution. This is our solution. So we look at two cases, or someone can even go further. If you don't want to use this formula, you can just solve it by yourself. You don't have to memorize. If you don't want to memorize it, if you are good in solving equations like the way they are, But once you know this formula, it becomes easy. But you have to know which case you are dealing with. But if you don't want to use this formula and you want to solve this by yourself, it's also very simple. What you have to do, you can just factorize. Minus 8x equals to 0. So it's very simple. You have x here, you x here, you factorize. 1x comes out. So what you need here is 5x minus 8 equals to 0. So what this is telling you that we have two terms, first term, another term. So it's saying that the first term and second term, if you multiply it, equals to 0. So obviously one of the term must be equals to 0. Then this x equals to 0, or in bracket 5x minus 8 equals to 0. So x equals to 0, or 5x minus 8 equals to 0. We are done with this one. So this will come here to 5x equals to 8. We are looking for 8. Then x will give us what? 8 over 5. So we have our solution just like before. So it depends, maths, it has thousands of ways, but the beauty about it, we must have the same answer. So it's the same as this one. You can just use this formula and you have the answer directly, or you can solve it by yourself. So now we looked at two cases. You understand? The first case is where we have a missing linear term. The second case is where we have missing constant term. And in each of them, we were able to give formulas that you can use to know the value of x or the roots of the equation. Solving quadratic equation means, it also means finding the roots of the equations. So we have seen constant term where it is missing. We have seen linear component or linear term where it is missing, and we know the formulas to use it, or you can solve it directly if you wish. So let's look at the hard case whereby every term within the quadratic equation is present. Let's look at that. So I think we have a few minutes before this second session of the video goes off. But if it goes off, then we will be back, or I will be back again. Hopefully you will also log in as well. So let's look at okay. Let's look at the harder case. In the harder case, remember the standard quadratic equation is this. This is plus equals to 0. So in a standard, this is, let's say, the case 3. In case 3, P is not equals to 0. That is, the linear term is present. Q is not equals to 0, meaning that the constant term is also present. So if we have a situation like this, how do we go about and solve it? There are many ways to solve quadratic equation when we have all the terms, when we have all the terms present within the quadratic expression. So obviously there is a factorization is possible. We can use factorization. We can use completing the square. We can use completing the square, or we can use the quadratic formula. So we will look at an example whereby we will, however, these two, they work perfectly every time, but sometimes factorization doesn't work. So these two, they always work. All what we have done here, even with these other cases, like case 2, case 1, we can still use completing the square and quadratic as well, but it will take a lot of time. So when we have the third case whereby the linear component is available as well as the constant term is available, we have to decide whether we want to use factorization if it works. Factorization doesn't work all the time. It doesn't work all the time. So there is a formula for each of these things.